Very good morning, all of you. Already we have discussed how to evaluate left hand limit and right hand limit at a point, and also continuity of a function at a point of its domain. Now we discuss on finding the values of a constant given in the definition of a function when it is continuous at an indicate point. On finding the value of a constant when it is continuous at an indicated points. A function fx is continuous at x equals to a if and only if limit x tends to a minus of fx equals to limit x tends to a plus of fx is equals to f of a. But limit x tends to a minus of fx equals to limit x tends to a plus of fx implies limit x tends to a of fx exists. Thus, fx is continuous at x equals to a if limit x tends to a of fx is equals to f of a. We will use this result in finding unknown quantity in the definition of a function when it is given to be continuous at a given point. Let us solve some problems. Problem 1. Determine the value of k for which the function fx equals to x square minus 9 by x minus 3, x not equals to 3, k x equals to 3 is continuous at x equals to 3. For what value of k fx is continuous at x equals to 3? Here, when x not equals to 3, that is x tends to 3 minus and x tends to 3 plus, the function is x square minus 9 by x minus 3. When x equals to 3, fx is k. Since fx is continuous, at x equals to 3. Therefore, limit x tends to 3 of fx is equals to f of 3. This implies limit x tends to 3 of x square minus 9 by x minus 3 is equals to f of 3. Your f of 3 is k. Implies when x equals to 3, the expression x square minus 9 by x minus 3 assumes the indeterminate or illusory form 0 by 0. So we factorize the expression. So limit x tends to 3 of x plus 3 into x minus 3 divided by x minus 3 is equals to k. Implies your x minus 3 will be cancelled. Limit x tends to 3 of x plus 3 is equals to k. Implies 3 plus 3 equals to k. Implies k equals to 6. Thus, fx is continuous at x equals to 3 if k equals to 6. Problem number 2. Find a if fx equals to 2x minus 1, x less than 2, a x equals to 2, x plus 1, x greater than 2. Determine the values of a for which fx equals to 2x minus 1, x less than 2, a x equals to 2, x plus 1, x greater than 2 is continuous. At x equals to 2. When x less than 2, that is x tends to 2 minus fx is equals to 2x minus 1. When x greater than 2, that is x tends to 2 plus, the function is equals to x plus 1. When x equals to 2, the function is a. So now we have to find LHL of fx at x equals to 2. Limit x tends to 2 minus of fx. This equals limit x tends to 2. Your function is 2x minus 1. This equals 2 into 2 minus 1 equals 4 minus 1 equals to 3. Similarly, RHL of fx at x equals to 2. Limit x tends to 2 plus of fx equals limit x tends to 2. Your function is x plus 1 equals 2 plus 1 equals 3. Here left hand limit at x equals to 2 is equals to right hand limit at x equals to 2, and f of 2. For x equals to 2, your function is a, so f of 2 equals to a. Since fx is continuous at x equals to 2, therefore limit x tends to 2 minus of fx equals to limit x tends to 2 plus of fx is equals to f of 2. Implies limit x tends to 2 minus of fx equals to 3. Limit x tends to 2 plus of fx equals to 3. F of 2 is a. Implies a equals to 3. Thus fx is continuous at x equals to 2 if a equals to 3.